Okay, we're reviewing for our quiz. We're about to name angles. So let me go ahead and give you some numbers here. All right, so if I wanted to talk about, let's pick this angle in particular. So this one here that I've highlighted in red, I need a name for that angle. Ryan, give me a name for that angle. Ryan says BCD. I agree. BCD is one correct name. Give me another correct name. Tom. Tom, did you hear that I called on you? I need another name for this angle besides BCD. Oh, I'm sorry. I didn't see it in the chat. Angle 4. Yes, angle 4 would work. There is one last correct name for this. Marissa, what else could you call that angle?
C? Or, no, sorry. I thought it was DCB. Oh, yeah, DCB. That would work.
DCB, right. So, and you know, just to reiterate for everybody, you can't call it C because there's so many other angles that could be C, right? So C is actually the only one that you can't use, but these are all perfect. When you're using 3, make sure that your vertex is in the middle. Perfect, perfect, perfect. Okay, let's make it more complicated now. I'm going to do this. I am going to split this angle. Gotta put, there's a point F, and let's call this angle 1, and this can now be angle 5. All right, how could I name this angle? This one here that I'm highlighting in green. How would I name that angle? Oh, Anthony, you get this one. How do you name that angle that I just highlighted in green? Anthony, you hear that I called on you, right? Oh,
Yeah.
good. All right. How do you name that angle in green?
Like,
Do you want me to give you an example? If I was going to name, for example, this angle that I just highlighted in yellow, I would call that one ACB, for example. So the one in green, how would you name that?
EFT?
So the E and the D are fine. The F is not, though. You
END?
need. Did you say ECD?
No, END.
No. So when you name an angle, right? This is super important. So make sure that you're with me here. When you name an angle, if you're going to name this whole, yeah, ECD. So you're just going to follow along the sides. You need 1 point from each side. So E and the D, those were fine. And then the middle letter has to be that vertex.
I got you. Okay.
Good. You can't name an angle like this one that I have highlighted in green, by just saying, you can't use numbers because there's 2 angles that make it up, right? So sometimes kids try and say, oh, well, it's angle 6, right? Because 1 + 5 is 6. It doesn't work that way when you're naming it. Let's see. What else could I? Oh, I know. What if let's talk about the measure for a minute. If I told you that the measure of this angle, the one in green, ECD, let's say it's 70 degrees. Oh, come on. There we go. Let's say the whole thing is 70 degrees. Then I tell you the angle 1 is, I don't know, let's say it's 50 degrees. What is angle 5's measure? Michael, you get that one.
Is it 20?
Yeah, it's just going to be 20, right? The whole angle 70. The one marked 1 is 50. I got to subtract here. I get 20. Perfect. Okay, let me scan. What else? Oh, yeah, the interior, exterior, and on questions. All right, let me put a couple of dots in this picture, and then we'll talk about them. So I'll use black here. So let's put a point G right there. Let's put a point H right there. And I'll put a point I right there. All right, let's do some true false. And by the way, I've called on everybody, so everybody's back in the mix. All right, true false. Are you listening? Make sure you're paying attention. True false, true false. Oh, Anthony, you get picked again. All right, Anthony. So true or false? Point G is in the interior of angle 2.
True.
Yes. True or false? Will's not back yet, is he?
No, not yet.
Okay. Jeremy, you get this one. True or false? Point G is in the exterior of angle 3.
Yes.
True. Yes, it is. G is outside of angle 3. You got it. Ryan, let's do this. How about H is on angle 5? True or false?
True.
True. Yes, it absolutely is. Okay. Michael, you're next. Point I is, what do I want to ask you? Point I is on the exterior of angle 3. True or false?
True.
It is true. Okay. Oh, you know what? Let me give you one more trick question. I'm gonna do this. All right. Let me see. Tom, this last one's yours. True or false? Point J is on the interior of angle 1. Tom says true, and I agree. So if you are thinking that that's false, right? Because you're thinking, okay, angle 1. Here's angle 1. J is not in that. Well, you're forgetting that angles go on forever. Those are arrows. They keep going. So all of this is the interior of angle 1. So J is certainly within that. All right, be careful there. We did a little bit with numbers already. All right, now it's the linear pair adjacent. We got to talk about that. Okay, so listen, on your quiz, you're going to have a bunch of choices. Let me clear all of this. So you're going to be able to choose if angles are adjacent, a linear pair, and then you're going to see other, I'm going to give you a big hint right now. So if you're paying attention to me, this is like, I'm giving you an awful lot of information. There's going to be other words on there that we haven't even talked about yet. We have not talked about alternate exteriors, for example. We have not talked about complementary. We have not talked about alternate interiors. Guess what that means? Those aren't the right answer. It's probably going to be one of these two things, or it could be none, I suppose. Do any of them have none? No, it doesn't even have none as an option. Okay, so spoiler alert, hello, if it's adjacent or linear pair, those are probably one of those two is going to be your answer. So if you see choices that you don't even know what those words are because I never taught them to you, there's a reason for that. We learn them next week. So obviously, if we haven't even learned them yet, they're not the right answer. So let me ask you a couple of questions. Let's do some more true false. I love true false. Oh, wait. Let me make a bigger diagram. Let's do this. Okay. More true false. Ready? Yes, this is open notes. Everything is. Oh, Lily, you get this one. Are angles 2 and 3 adjacent? True or false? Or yes or no, I guess, whatever. 2 and 3, are they adjacent? Yes, they are. Adjacent, remember, just means next door neighbors. That's all it is. Literally next door neighbors. Not across the street neighbors, right next door. Zoe is still not here, I don't think. Evan, how about angles 1 and 4? Would you call those adjacent?
Yes. No.
Yeah, they got to be right next door to each other. So 1 and 2 would be adjacent. 1 and 5 would be adjacent, but not 1 and 4. Okay. Marissa, how about angles 4 and 5? Are they adjacent?
Yes.
Yes, definitely next door neighbors. All right, let's move on to linear pairs then. So that was, I had you guys sorting a lot of those yesterday with linear pairs. So let me just remind you what a linear pair even is. It's two angles that together, first of all, they have to be adjacent, but they also have to add up to be 180. Which, if you remember, 180 is literally just a straight line. So let me give you an example of a pair that is a linear pair. 3 and 4. 3 and 4. So here's angle 3, here's angle 4. You put them together. See how it makes half a circle? Look at this. They make a perfectly straight line together. That's what you're looking for. That's what makes a linear pair. Okay? If I had asked you about angles 2 and 3, let's say, 2 and 3. If I tried to do the same thing and trace angles 2 and 3, first of all, that is not a full half circle, right? I'm missing part of it. And if I go to trace this, hello, that is not a straight line right there. That's a bent, broken line. So no, 2 and 3 do not form a linear pair. Does that make sense? I hope. Okay, so now let me ask you guys some questions. Okay, Jay, you get this one. Angles 4 and 5, do they make a linear pair?
Yes.
Yes, they do. They're right next to each other, and together they make that straight line. Perfect. All right. I asked everybody a question, so now you're all back in again. Okay. No, Will still. Okay. Tom, you get to go again. Oh, Anthony is back. I didn't know he left. Okay. Tom, angles 1 and 2, are they a linear pair?
Which angles again?
1 and 2. I'm asking if those are a linear pair. So they are not going to be. So let's look at them. If I, first of all, if I sort of make this fan, that's not a half circle. I need it to be a full half circle, and that's not. And then if I trace them, look at this. That's not a straight line, right? That's bent. So it has to be a perfect straight line. So one more time, the example that I had given were 3 and 4. Look at this. 3 and 4 together. There's half a circle. And this is a perfectly flat straight line. That's what I'm looking for. Okay? So linear pair can't be 1 and 2. How about, Lily, tell me about angles 1 and 5. Are those a linear pair? Yes or no? She says no, and I agree. So 1 and 5, look at them. 1 and 5. That's not a full half circle, is it? Nope. If you trace this, look at this. You cannot, that's not a straight line. That's bent, right? Not a straight line. It's got to be a straight line, and that if you fan it, it's got to make a perfect half circle. So let's find maybe one more that is. There's not many in this diagram. We already said 3 and 4. We already said 4 and 5. All right, I'm going to give you a trick question. Okay, trick question now. 1 and 3. Angles 1 and 3. Do they make a linear pair? 1 and 3. Trick question. I'm not going to call on anyone for a trick question. I want you to come up with your answer for yourself. Angles 1 and 3 only. 1 and 3. Because remember, a linear pair can only be 2 angles. 1 and 3. Ooh, tricky. So the answer for 1 and 3 is no. And I know you're like, oh, but this is a perfect straight line. What's up with this? Just 1 and remember, there was 2 things that are required for linear pairs. And the first thing was that they have to be adjacent. 1 and 3 are not next door neighbors. 1 and 3 are not adjacent to each other. So even though this is a straight line, I'll give you that. That's true. Look, 1 and 3. That's not a full half circle, is it? I'm missing angle 2. So I actually can't say that those 2 are a linear pair. That's a tricky question, but be mindful of that, okay? I'm going to do, I'm going to make a different style diagram real quick, because these are really important, and I think that this is sort of where we struggled the most yesterday, from what I could see from the work anyway. All right, so here's another diagram. I'm going to ask you the same kinds of questions. Anthony, you get this one. Angles 4 and 5, Anthony, are they a linear pair?
Yeah.
Yes, they are. Look at them together. Full half circle, straight line. Got it. All right. I still don't have Zoe, do I? I don't think so. Jay, how about angles 2 and 3? Linear pair, yes or no?
No.
Correct. That is not a full half circle. If you trace this line, it's bent. So no, they are not a linear pair. Okay, one last question before we move on. Gosh. Jeremy, angles 1 and 5. Are they a linear pair?
Yeah, no. Yes.
I'm so excited for you. Yes, 1 and 5 are. Yes, watch. Full half circle, and it makes a straight line. So yes, they are a linear pair. Yes, yes, yes. All right, guys. Let me keep scrolling here, see if there's anything else that we need to cover. There are a bunch of questions that are like this, where I give you some sort of a line, right? And if I tell you this one's 100, what's this one? Okay, so let me see. Let me call on some people. Marissa, what's X gotta be in this case?
80.
80, right, because if they are a linear pair, they have to add up to be 180, right? Because that's a full half circle. So if that one's 100, that one's got to be 80. Perfect. Okay. They're going to try and make the diagrams a little bit trickier. They might do something like this. And they might say, okay, this is 120. What's this one? Who cares about all this? It's literally the same diagram I just made. They just added one extra line. Who cares? I don't even care about that. This still has to add up to be 180, right? So what's the value of X this time, Ryan?
$60.
Yes, just 60, right? So don't get thrown off track if they just are like try it. You might see a diagram like this, where this is, I don't know, let's say this is 70, and I want to know what that is. Who cares about this little line going down here? It's irrelevant. It doesn't have really anything to do with this. So ignore it. What must the measure of x be in this case? Evan, what do you say?
Wait, you're supposed to answer?
Yeah, I want your answer for x, Evan.
What was the question? I forgot.
What's the answer for x?
What?
What's the answer for x?
That is.
So
Wait.
80 equals
This whole thing, if anytime you have a straight line, it's got to add up to be 180.
110.
Yeah, so x has got to be 110. All right, so you have a couple of questions like that. And then the last two are some of those algebra questions. So let me give you one or two of those real quick. And though I think you guys have gotten a lot better with those. Let's see. All right, let me do, so here's angle ABC. And I'll tell you that this is angle 1, angle 2. And let's just do this. How about I tell you over here in words, if measure of angle 1 equals x plus 3 and measure of angle 2 equals 4x plus 2. And measure of angle ABC equals, yeah, let's go with 90 this time. Why not? Find x. So I'm going to give you something along these lines. So you are going to have to write an equation and then solve for x. So take a moment, write your equation, and then solve. And I will tell you, you don't even have to think twice about writing the equation if you start with our model equation that we've been using this whole time. What's the model equation, you're saying? Don't worry, I'll tell you. If you look at this diagram, it's very clear that whatever angle 1 is plus angle 2 together, it equals the whole big angle. So that's what I'm doing here. This is my model equation. Angle 1 plus angle 2 is going to equal the whole big angle, which in this case is ABC. All right. Now, the numbers might change based on your diagram, right? Maybe your diagram has angle DEF instead of ABC. Who cares? It's the same idea, though. You're taking this littler angle and this littler angle, add them together, and it always equals the big angle. Okay? So now all I have to do, now that I have this model equation, I just take the information and just pop it in. So let's see. Angle 1 is just x plus 3. Angle 2, oh yeah, that's just 4x plus 2. That's easy. And then the measure of angle ABC, oh, they told me it was 90. All right, great. Now I have an equation, and I should just be able to solve this equation and get my answer. And then be done, right? So let's see. X plus 4x is 5x. 2 and 3 is 5. So now I'm just going to solve this equation like I always do. Minus the 5. 5x equals 85. I'm going to put it over here because I'm out of room. And then just divide both sides by 5. So, gosh, what is that? I have one answer for 17. That sounds right to me. 50, 35. Yeah, 17. Perfect. That's it. The only way it gets more complicated is if I change up the numbers a little bit on you. So I'll do that here. I'll give you one more where I sort of change the order that I give them to you in. So let's see if you can still get this one right if I do this. All right, let's say that angle 1 is now 3x minus 10. And the measure of angle ABC, let's make that 4x plus 40. If I could fit 40 in there, of course I can't. Hold on, I'll squeeze it in there. 4x plus 40. There we go. And measure of angle B is, oh, I don't know. I'm just making numbers up here, so I have no idea if this will come out nice or not. Let's go with that. So go ahead, write your equation and see if you can solve for x. Oh, I think this does come out nice. Oh, wait, does it? It might come out. Hold on. I might have to change something real quick. So you know what? I don't actually have to change anything. Do I? Yeah, I do. All right, hold on. Sorry. So the problem with how I put my numbers is that you're going to get a negative value for x, which is not necessarily wrong, but it is wrong if you take it and plug it back in and it turns an angle into a negative. So what I need to do is change, instead of angle 2 being 30, let's make it be 80. And then I think this should work. Sorry about that. Yes, and I think this works out well now. Okay, I got a good equation. Yes, all right. So, guys, you literally don't have to do anything different as long as you're still looking at the diagram and you're still like, okay, well, I'm still going to take angle 1 plus angle 2, and together they're going to get me the whole big angle, ABC. So now I'm just filling in these pieces. Angle 1 is 3x minus 10. Angle 2, this time is just 80. Okay, whatever they tell you it is, just stick it in there. And ABC, be careful, is 4x plus 40. So that would go here. So this would be your correct equation. Now all you have to do is solve it. So let's see, I have a negative 10 and an 80. So those two together would get me 70. And now I'm just solving this equation. Remember, when you have x's on both sides, you just need to subtract to get them together. So now I've got 70 equals x plus 40, and just minus 40 from each side. So that's how I get a correct answer of 30. Yes. Okay, so that's it. Does anybody have any questions before we take our quiz? Nothing? Okay, well, I've retaught you everything I think you need. Let me